So, this is the 5th video of the day, actually. Number 1, you have the cube root of -8 times x to the third. We're going to split the root like we always do. The third root of -8 and the third root of x to the third. Now, some people remember from square roots that you cannot have a negative in there. However, this is not a square root. It's actually a third root, and you are able to take the cube root of a negative number. Let me repeat what I just said. You cannot take the square root of a negative number that produces an imaginary number, but you could take the cube root of a negative number. Okay? Once again, if I were to say the square root of -9, it's not 3, it's not -3, because -3 squared is +9, or +3 squared is also +9. There's no way that you could get a -9 in there. So that's why the answer is 3i. It's imaginary when it's negative. But when we take a look and think about the cube root of -8, instead of the square root, the cube root of -8, there's actually an answer. That answer is -2. Because if you went -2 times -2 times -2, that will give you -8. So you could do the cube roots of negatives. Does that make sense? Yes. All right, so what is the cube root of -8? -2. And how about the cube root of x to the third? That's just x. So your answer, number 1, is simply -2x. No more roots, no more cube roots. Let's go to number 2 here. Again, we are going to split that third root. We're going to split that third root, put it on the 24, and also put that third root on the n to the 4th. Now, is 24 a perfect cube number? No, Trixia. 24 is not a perfect cube number. Let's see, give me a perfect cube number. What's 2 times 2 times 2? 8, that's a perfect cube number. Now, could we rewrite 24 to look like an 8 times something? Yeah. So let's rewrite 24 to be 8 times 3 because 8 is a perfect cube number. So when you split it, you'll be able to do the cube root of 8. What is the cube root of 8? 2, because 2 times 2 times 2 is 8. And then that cube root of 3, you're just going to bring it down. The cube root of 3. Now for this other one, we need something that's divisible by 3. Remember, the third root is the 1/3 power, so you want something that's divisible by 3. So you're going to rewrite that n to the 4th as n to the 3 times n. That way, when you split the third root, you'll be able to do this one right here. The third root of n to the third, that's just n, and the third root of n just comes down. So this giant ugly thing right here is the answer. We just need to organize it and make it a little nicer. We're going to put the 2 and the n as the first part of our answer, and then the cube root of 3 and the cube root of n, we're going to put them together underneath one cube root value. So, moving on to number 3. We have the third root of 108 x to the 4th. Let's make this smaller, easier problems to deal with. So let's split that third root. The third root of 108, the third root of x to the 4th. Now, since we're dealing with third roots, it'd be nice if we could have perfect cube numbers. So if we think about perfect cube numbers, the very first perfect cube number is 1, but we're not going to use it. 2 times 2 times 2 is 8. That's a perfect cube number. 3 times 3 times 3 is 27. That's a perfect cube number. 4 times 4 times 4 is 64. That's a perfect cube number. And 125, 5 times 5 times 5. But 108 is not one of those, so I want to rewrite it with multiplication to get one of those perfect cube numbers. So we could use calculators. If you get a calculator and go 108 divided by, let's say, 27, or 108 divided by 64 is not going to work. Okay, you could use the factor tree also if you wanted to, right? Anybody want to use a factor tree? Yes? Okay, let's try the factor tree. Since we can't see it off the top of our heads, again, you could use a calculator if you wanted to. But 108, we're going to break it down to 9 times 12 with the factor tree. 9 becomes 3 times 3. 12 becomes 3 times 4. And this is a cube root, which would mean that you want something to repeat 3 times. 1, 2, 3. The 4 is something else. So these 3, you're going to be able to pull out of the cube root. So here's your cube root. You're going to have a nice, beautiful 3 on the outside, and there's a 4 on the inside. Okay? So the cube root of 108 is really 3 cube root of 4. Now, if you don't like this factor tree method, which I personally don't like it that much, I would go back and simply think, which one of these could I use to change with multiplication to get 108? And that would be 27 times 4, right? This perfect cube number 27, if I went 27 times 4, that would give me the ability to split that cube root, and the cube root of 27 will give me 3, and the cube root of 4 is going to stay like that. So it's totally up to you. If your mind blanks out, you could use the factor tree, or if you have a calculator and you're able to do it, you could rewrite with multiplication to get 27 times 4. Anyhow, right here we have a cube root of x to the 4th, and we should all know that a cube root is the 1/3 power, which is really like dividing this power by 3. Okay, so we want a power that is divisible by 3. 4 is not divisible by 3, but 3 is divisible by 3. So what I'm going to do is I'm going to rewrite x to the 4th as x to the 3rd times x to the 1. That way, when I split the 3rd root, I'll be able to do this first one right here. The 3rd root of x to the 3rd, that's just saying 3 divided by 3, that's 1. So the 3rd root of x to the 3rd, that's just x. And this next one, the 3rd root of x, that's just the 3rd root of x. You don't mess with it. The 3rd root of x. So this is our answer. We just need to rearrange it. So we do have a 3, we have an x, and we also have the 3rd root. But let's put the 4 and the x together inside that 3rd root. So there's my final answer, 3x times the 3rd root of 4x. Let's jump to number 4. There's a -3 on the outside that we're going to end up multiplying by the 3rd root. Okay, keep this in mind, guys. This is not -3 to the 3rd power. That belongs right here in the root. I don't know why the computer leaves it out here. It should be closer right here to this area inside of the root. So that's really the 3rd root. This is really a multiplication of 3 that you're going to do separately. So let's worry about doing the 3rd root first. Let's take this -3 and just bring it down and multiply it by our answer at the very end, okay? So let's deal with the 3rd root of 162 x to the 9th y to the 4th. That will be the 3rd root of 162. That will be the 3rd root of x to the 9th, and that will be the 3rd root of y to the 4th. So 162, I need a perfect cube number that I could use with multiplication to rewrite the 162. So I know that 8 is a perfect cube number. I know that 27 is a perfect cube number, right? 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. That's a perfect cube number. 5 times 5 times 5 is 125. So we're going to be dealing with one of these 3 numbers. So the easiest thing to do is simply grab a calculator and do like 162 divided by any of those perfect cube numbers, like 27. 162 divided by 27 on a calculator gives me 6. So I know that 27 times 6 is 162. 27 times 6 is 162. So when I split that 3rd root, I will be able to get this first answer, which is what? What's the 3rd root of 27? 3. And the 3rd root of 6 is simply going to stay the 3rd root of 6. It comes down. Now, how about this next part right here? What's this answer going to be? X to the what? X to the 3rd, exactly. Why? Because the 3rd root is really the power of 1/3, which makes it a division problem. You take this power and divide it by 3. Okay? So it would be x to the 3rd. If you want to show your work, you have to remember that the third root could be rewritten as the power of 1/3, and then you have the x to the 9th on the inside, and a power to a power you multiply. So you'd have x, 9 times 1/3 is really 9/3, and 9/3 is really 9 divided by 3, which is where you get the x to the third from. Now the last one's not that easy, that third root of y to the 4th. See, you want this power to be divisible by 3, and it's not. So what are we going to do? We're going to rewrite it with multiplication to get something that's divisible by 3 right here. Y to the third times y to the 1. That's really y to the 4th, right? Both of these add up to give you 4. So I rewrite it to that. That way when I split the third root of y to the third, what does that become? Just y. And the third root of y is simply the third root of y. So this is our answer, but we need to arrange it nicely. We're going to multiply the -3 times 3, and we're going to get a -9. We're going to write also the x to the third and the y right out there, x to the third y. And last but not least, we're going to take the radical and put them underneath 1 cube root. So the 6 goes in there and the y goes in there. And that's your final answer for number 4. Could you have used the factor tree? You could have if you wanted to. It's up to you. Let's go to number 5. What's our first step? Split it. The 5th root of 32. What times itself 5 times gives you 32? 2. And if you don't know, just guess and try it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th really is 32. So the 5th root of 32 is what? 2. All right. Now, the 5th root of x to the 10th, what's the answer there? X to the 2nd. Because remember, 5th root is really dividing this power by 5. 5th root is really the power of 1/5, which means that 10 divided by 5, that's going to be 2. So x to the 2nd is the next part of your answer. And last but not least, the y to the 4th, you want it to be divisible by 5, and there's nothing you could do about that, so it would have to stay exactly like that. The 5th root of y to the 4th. There's your final answer, 2x squared, 5th root of y to the 4th. Last one down here, the 6th root. We're going to split up that 6th root to each of them. So I've split them all up, and now we're going to work on each of them individually. So what times itself 6 times will give us 128? Well, we could try 2 to the 6th. When we go 2 times 2 times 2 times 2, 6 times, we will get 64. And we see that 64 is really half of 128. So we could go 64 times 2 instead of 128. That way, when we split the 6th root, this first part would be 2, and the 6th root of 2 is going to stay the 6th root of 2. Now this one's pretty easy because the 6th root is really the 1/6 power, which means that we need to take that 18 and divide it by 6, which would give us what? 3. Moving on to the y's, y to the 24th with the 6th root on it, it's really saying 24 divided by 6, what do we get? Y to the 4th. And last but not least, the 6th root of z. Could I even do that? No, so you're just going to rewrite it, the 6th root of z. So this whole thing right here is our answer, but let's rearrange it. Let's put the 2 out there, the x to the 3rd, and the y to the 4th all together. 2, x to the 3rd, y to the 4th. And then let's take our 6th root of 2 and 6th root of z and put them together underneath one single 6th root. That way it'll be 2z. So that would be your answer, your final answer to that question. Dang, today was a long day. I apologize, but we're done.
What about 1 and 2?